Now we can say even more in terms of the circular model, and this should impress you. The point moving on the circle at a given instant has a velocity tangent to the circle. So that's the velocity of our reference point. Okay? That velocity has an x component. So I'm going to call this v ref. And the x component of this reference velocity is just the projection of this vector onto the negative x direction, or if you prefer, onto the negative I vector. So this is the projection onto the I vector of v ref, and that equals Vx, the actual velocity of an oscillator moving according to this model. Okay, just this. Okay? Now, we note that the magnitude of v ref is what? Well, if we understand these relationships for rotational motion and everything else, okay, we can say that v ref is omega A. Okay. Also, well, I don't want to get too far into the angle, but you can think about this. See if you can prove this. I think we're going to try to do this in our very last class. Okay. Our Vx is omega A times the cosine. I'm sorry. It's negative omega A times the sine, because we're talking about the x component here, which is a cosine. And we can look at the triangle and see why the angle is the cosine, or why the angle here to use is the sine. Okay. It's simply that this angle here is equal in magnitude to this angle. Okay. And it's the sine of this angle, and this angle is just at the same angle with the x-axis as this angle. I don't want to spell out the trigonometry of it here. You should know enough trigonometry to figure out exactly why Vx is this. And of course, by the trigonometry of the circle, the geometry of the situation, this turns out to be equal to the derivative of this. So we don't even need calculus to get this. Although calculus is really the easiest way. Yeah, taking a derivative of this is really easy if you know the calculus. Working it out with the angles and the similar triangles and so forth, and getting all the signs right on this model, well, that's a high school question, okay? But it's a challenging high school question, and one that you probably have to think about a little bit, okay? So, very important connections here. And we can also, I'll just point to it because I don't want to clutter up the picture anymore. The acceleration is centripetal. Acceleration is your centripetal acceleration. That's omega squared A. Okay. Now, maybe if you want v squared over r, but then v is omega A. Well, omega squared over r, but r is A, and v is omega A, so that you square omega A, divide by A, get omega squared A. Okay? That's the magnitude of the centripetal acceleration. And the x component of that acceleration will be negative omega squared cosine omega t plus phi. And the negative times the cosine is pretty obvious because you're going back toward the origin. Okay, the r vector here goes out away from the origin, giving you a positive multiple of the cosine. The acceleration vector, centripetal acceleration vector, goes in the opposite direction, so it's going to give you a negative multiple of the cosine. So all that hangs together into a very, very profound and useful model of simple harmonic motion that we definitely want to talk about before we wrap everything up.